for this problem, we're going to calculate the force on the charges. So let's label the charges. Okay, and now just to clarify the charge here, 6 microcoulombs is equal to 6 times 10 to the minus 6 coulombs. So we have the same for 1.5 microcoulombs as 1.5 times 10 to the minus 6, and so on. Okay, so now if we're going to solve for the force on Q1, the force on Q1 is actually the force on Q1 due to Q2 plus the force on Q1 due to Q3. So each of these charges exert a force on Q1. So force on 1 is going to equal the force on 1 by 2 plus the force on 1 by 3. So let's figure out the force on 1 by 2 first. If we look here, here we have charge 2, and this is Q1, this is Q2. Because they're both positive, this Q2 is going to push Q1 away, so the force is going to be in the negative y direction, and the force on 1 by 3, if this is Q1 and this is Q3, since Q3 is negative, it's going to pull the force in the positive x direction. So let's define our coordinates. This is positive x to the right, and this is positive y up. We're only going to be using the x coordinates, so that's all we'll need to think about for now. Alright, so now let's calculate our forces. So we have force 1, 2 is equal to K Q1 Q2 over R squared. And R squared is the distance between these two charges, Q1 and Q2. And that's going to be 3 centimeters. Okay, so I have 9 times 10 to the 9th Newton meter squared per Coulomb squared times 6 times 10 to the negative 9, or I'm sorry, 6 times 10 to the negative 6. Oops. Negative 6 coulombs times 1.5 times 10 to the minus 6 coulombs, and then divided by R is going to be 0.03 meters squared. And I find that F12 is equal to, when I multiply that out, I find that it's equal to 90 newtons. And this is in the negative x direction. So I'll put a negative here and I'll put an x hat over here to identify to the left is that this is to the left. A negative means it's in the negative x direction. Okay, now F13 is the force on 1 due to 3, and that's going to equal K Q1 Q3 over R3 squared over R squared, and this is the distance between 1 and 2, and this is the distance between 1 and 3. So here I have 9 times 10 to the 9th Newton meter squared per Coulomb squared times 6 times 10 to the minus 6 coulombs times 2 times 10 to the minus 6 coulombs divided by, and now if I look at the distance between them from Q1 to Q3, that's going to be 3 plus 2 centimeters, so that's going to be 5. So 0.05 meters squared. And so when I plug the numbers in, I'm going to have F13 is going to equal 43.2 newtons. And now I'm looking at my units here. So I have coulombs here and coulombs here, coulombs on the bottom squared here. So these coulombs cancel. And I have meters squared here and I have meters squared here. So I end up with newtons. So those units make sense. And now let's just look at the force on Q1 due to Q3. and I find that it's going to pull, because this is positive and this is negative, that this charge is going to pull this one to the right. So that means my force is going to be positive. So now when F1 is equal to F12 plus F13, and I find that the answer is a negative 46.8 newtons. And that's in the x direction, so x is to the right, but we have a negative, so it's in the it's to the left. All right, now what about, so there's F1, that's the first one, and now we're looking for the force on Q2. And so we have the force on 2 is equal to the force on 2 due to 1 plus the force on 2 due to 3. And because of Newton's law, I know that that the force on 1 due to 2 is equal to the force on 2 due to 1. So I already know F21. So F21 is equal to F12, and that's equal to a negative 90, or 90 newtons, and we'll see what the direction is in just a sec. So I go back up here and look. On 2 due to 1, so these are both positive, and so it's going to push it to the right. So this charge is going to push Q2 to the right. So that means I need a positive number here. So this is going to be a positive. Okay, and now for F23, I have Q2, erase that. KQ2 times KQ3 over R Q squared, and that's going to be the distance between 2 and 3. And so when I plug those numbers in, I find that that's equal to 67.5 newtons. And that's also to the right because charge 3 is negative, so that's going to pull Q2 towards it. So my F2 is going to equal these two added together, and that becomes 157.5 newtons. And that's in the positive x direction, so I have a positive number here. And now if I want to think about F3 is going to equal F31 plus F32. And now I know F31 and F32 because, so F31 is going to be the same as F13. So I end up with 46.8 newtons. And if I think about direction, it's going to be in the negative x direction because it's going to, the Q1 is going to pull Q3 to the left. And now F32 is going to be plus a negative 67.5 newtons, and that's in the again in the negative direction because that Q2 is positive, and so it's going to be pulling that Q3 towards it to the left. So I end up with 111, about 111 newtons in the negative x direction, so to the left.